Video, I'm going to do maximum difference between increasing elements. So, given a zero indexed integer array nums of size n, find the maximum difference between nums at I and nums at j, such that I is smaller than j. Okay, so I comes before j, and they're both in the array. Return the maximum difference. If no such I and j exists, return -1. Okay, so basically what we need to do is we need to find the maximum difference between any two elements in the array, increasing from left to right. So in this case, I and j have a difference of 4, which is bigger than any other possibility here. So in this case, there's no such difference because it's decrementing. So yeah, no such difference because it's decrementing, so there's -1. In this case, I equals 1 and j equals 10. Interesting. So, how can I do this? I'm thinking that I can do some form of a two-pointer approach. So I can start with I can start with my left pointer at the start, and I will keep on iterating until the left pointer reaches the lowest value from the start. So in this case, left pointer would start at 7, and then since the next value is smaller than 7, I would go to 1, and eventually I would leave it there, so the lowest value from the start. And then the right pointer would pick up after that value, and then I would and then and then I'll keep iterating the right pointer, and if it is greater than the current pointer, I will make that the new right pointer. Otherwise, if it's I'm just trying to think about how I can do this. Hmm. Okay, so I do think it's going to involve two pointers, but I'm not entirely sure how I can ensure that I'm checking everything I need to be checking. Um, huh. Okay, so I think I've got it figured out. Um, just a little bit of thinking I did, but I'm gonna go ahead and get my smallest. We'll call the left pointer smallest, and that'll be at the smallest variable from the left. Then I'll take my right pointer, pick up from right after smallest, and calculate the difference at each step. Um, and it'll just keep going. Um, and then it'll make the comparisons every time and see if it's bigger than the current maximum. Um, but only if it is bigger. So if this is the max, I'm going to check this. But then if when it goes to 4, if 4 is not bigger than largest and it's not smaller than smallest, it's just going to skip over it. If it's smaller than smallest, then smallest, so the left pointer is going to become 4. And I'm just going to do this until I get to the end. So let's go ahead and code that out. So int max equals -1, because that's the default. Okay, so int smallest equals 0 while nums at smallest while nums at smallest is greater than nums at smallest plus 1, and nums and smallest plus 1 is smaller than nums dot length, because I don't want to, if it's continuously going to go downwards, I don't want to get out of bounds. Smallest plus. Okay, so now smallest should be the index of the smallest from the left. Okay, so now int largest equals list plus 1. Okay, let me okay, so while the largest is smaller than nums.length, okay, let's do int car max equals nums at largest, nums at largest minus nums at smallest. So that's the difference. Max equals math dot max max car max. Okay. Okay, so there we go. Now Okay, so actually, let's do this. Let's do int I equals largest, and then while I is smaller than nums.length, okay, so if I we'll do this here too. Int largest equals 0. And then we'll do I equals this right here. And then while I is smaller than nums length, if I is greater than largest, sorry, if nums at I largest, then largest equals I, and then we'll do these. So then we'll now make our comparison with the new largest. Okay, so if nums at I is greater than largest, okay. Otherwise, if nums well, largest doesn't necessarily have to be bigger than the previous largest, because if the smallest is just smaller, then the largest may not be as big, but it'll still be more of a difference. So, okay, let me just see where I'm at right now. So, while nums at smallest is greater than nums at smallest plus 1, and smallest plus 1 is smaller than nums at length, smallest plus plus, okay. So int I equals smallest plus 1, so while I is smaller than nums at length, while I is smaller than numbers.length, if largest, if a number is at I is greater than largest, then largest equals I is greater than largest. Largest equals I. Okay, I think I'll just okay, so we'll do if nums at I is smaller than target, sorry, smaller than smallest, smallest equals I, and then we can do I don't think we need this because it doesn't need to be bigger than target, but we should just check it anyway. So while I is smaller than nums at length, if nums at I is smaller than smallest equals I. Otherwise, if we didn't change this, actually, I think we do need largest. Otherwise, if nums at I largest equals I, car max equals nums. Okay. Smallest equals I. We'll do largest also equals I. Okay. I plus return max. Okay, let me just walk through this code. So max equals -1. Default. Car max smallest equals 0, largest equals 0, while numbers at smallest is greater than smallest numbers at smallest 1. And smallest plus 1 is smaller than numbers at length, smallest plus. So we're going to get to the lowest value from the left. Then we're going to enter our loop. So int I is smallest plus 1, so picking up right after the lowest value, while I is smaller than numbers.length. If numbers at I is smaller than numbers at smallest, then smallest becomes I. And then largest becomes I. Although that won't happen the first time because we've already reached the smallest. But otherwise, numbers at I, if it's greater than largest, which it would be, it becomes a new largest. And we make our comparison with the largest and smallest difference, and then we set that to the new max, then we increment I. Okay, let me give it a run. Okay. Smaller, no, smallest plus 1 is smaller than nums.length minus 1. I think we might need to do that. Okay, there we go. Passed all test cases. Let's see if it works when we submit it. Okay. Okay, I think smallest should be I think smallest should be into integer.min value and then largest should be the min value as well, but not 0. Car math equals okay, let me just okay, if max equals 0, return -1, otherwise return max. Let's try this. Okay, there we go. Perfect. I think the problem here is that it's just defaulting to 0. instead of -1, which I could fix somewhere here, but I think this is also a fine solution, just taking the default value, returning -1. Okay, perfect. There we go.